Okay, so we did this. We passed back your test, and you made wonderful grades, most of you, and you know about the retest. Okay, so what we are going to be doing next is we are going to be solving logarithm equations, so I guess we better learn what logarithm equations are. Please look at your notes and please stop talking. This is the kind of problem we had on the test. We had graphing like that. Is that growth or decay? Growth. And we started off with this equation right here. That was the first exponential we graphed. And so what this is it has the points, and it shows you how you get to the y values, and then this table right here is what's on the graph over here. And that's what we've done before. And then the logarithm is an exponential inverse. How do you get an inverse? You switch the x and the y to get an inverse. So that's what they did to get this table right here. They took this exponential function table and they switched the x and the y. So would you please put these points right here on that graph paper? How do you put negative 1/4 and positive 1/4 on the graph table? Where does a 1/4 go? It is really, really close in here to the y-axis, as close as you can get it. And then 1/2's a little bit easier to graph, and negative 1, 1 and 0, 2 and 1, so here is the graph. What does it do as we continue to go to the right, as the x values get bigger and bigger and bigger? As the x values get bigger, these will get bigger also. And so this continues like that. Does this stop right here? Could we have put some more numbers in the table? If that was a 1/8, that would be a -3. If that was a 1/16, that would be a -4. And it would continue on and on and on. And do you see that it would continue to get closer and closer to the axis because those fractions are getting smaller and smaller and smaller, but it's never going to touch the axis. What do we call that if it is getting closer and closer and closer, but it is never touching? That is an asymptote. So for this graph, this y-axis is the asymptote. This is the exponential graph. This one is the exponential graph. This one is the inverse. The inverse of an exponential is called a logarithm. And so the exponential, the one that we started with, has an asymptote at y equals 0. It has a domain of -infinity to +infinity. It has a range of 0 to infinity, and the inverse, one more time, how do you get an inverse? Switch the x and the y, so if that's y equals, the inverse is x equals. That would be, this right here is the asymptote, and it's x equals because it crosses the x-axis at 0. If it's an inverse, the x and the y switch places, so what's going to happen to the domain and range? The domain goes with x, so it's going to switch to the range. The range goes with y, and so for the inverse, it's going to go with the domain. So the domain and range are going to switch because the x and y switched. Now, coming up later, we're going to go into much more graphing. But before we do the graphing, we are going to solve log equations. This is the graph of a log equation. And let's go into it a little bit more about what is this log equation. And log, of course, is the abbreviation for the word logarithm, because we don't want to say a word that is that long. We are going to abbreviate it. And if you will go, oh wait, I'm a step ahead of myself. And so this log function, you can see on the next page of your notes, there's a lot more writing on there than we usually give you. There's a bit of an explanation about what a logarithm is. A logarithm was used to help calculations because in the ancient days when I was in high school, we did not have calculators to help us calculate stuff. We had this thing right here that's called a slide rule. And it was 2 pieces of wood, and then this middle section slid up and down inside. And so the way it would work is, just a simple example, if you wanted to multiply 2 times 3, you would line up the 2 and the 3 using the slider, and then it would tell you that the answer is 6. Now, obviously, we wouldn't need a slide rule to figure that out, but to help you do more complicated multiplications, you could use a slide rule, and the logarithms were one way to make our multiplication easier way back when, 100 years ago when I was in high school. I was also one of the last classes to use a slide rule. My brother, that's 2 years younger, when he came through high school, he got to use this new exciting thing called a calculator. And so that it was just a way to help make our multiplication tables easier. And so there are 2 major kind of logarithms that are used in science that we're going to be talking a whole lot more about: common logarithms and what's called a natural logarithm. And we will be talking about what the difference is coming up. And if you are anybody in here interested in computer science? So in computer science, you often use a base 2 logarithm. So many times I have people come to me and say, what do we use this stuff for? Well, some of it's just pure math that we learn in here. Just what can you do with the numbers? When you use it, that's called applied mathematics. And we don't have enough time, we don't do a lot of applied mathematics in here, but we will be doing more with this section. One of the uses for the logarithm equation is decibels. Anybody know what decibels is? It says what? Decibel. Not decimal, decibel with a B. Sound. And so some of you have the decibel set so high on your earbuds, you're ruining your ears. So decibel measures how loud the sound is. That is a log equation. Any of you done chemistry, done pH problems in chemistry? That is based on a log equation, based on the log of the acidity in whatever liquid it is. If you are lucky enough to have a swimming pool, you have to go around measuring the pH in your swimming pool so you can have nice, pretty water. And so, any of you musicians and know what an octave is? That is based on a log scale. Oh, I had to look this one up. I did not know this word. What is psychophysics? It's also based on a log scale. That's not psychotic, and it's not a psychiatrist. It's psychophysics. What is that? Well, if I walked over here and hit him in the face, his brain would think, oh, that hurts. And so psychophysics is the relationship between the physical, hitting him in the face, and his brain connecting that and making sense of that and saying, oh, that hurts. So the connection between physical and mental, that's psychophysics based on logs. Accounting, do you know what accounting is? Accounting is where you keep books in a business, how much money you get in and how much money you get out and pay out, how much you have and how much you owe. Well, what would forensic accounting be? When I have heard this term, it's used when people embezzle money. Do you know what that means? They steal it, but they try to hide it in their accounting, and so a forensic accountant would go in there and look very closely at all the details and make sure everything is done correctly or not, or find it if there's a mistake. We know what prime numbers are. There's a formula for finding prime numbers, and that includes a log. And many other scientific formulas. I forgot to put one of the most well-known up here. One of the most well-known formulas is a Richter scale. Do you know what a Richter scale does? It's how to measure earthquakes. So, if we have an earthquake of 2, that's not a real terribly big earthquake. But if we have an earthquake of 4, that's not just 2 times bigger. That is 100 times bigger because it's based on a log scale. And so we're going to be explaining what all of that means as we study about these logs. So the next thing we need to do is fill in our notes. Do you see where this box is on your notes? This is the traditional definition of what a log is, but it has been confusing and it's totally correct, but it has been confusing to my students to have this X and Y in the definition, and then you have X and Y in a different place in your problems that you're trying to solve. So above this box, I want you to write this down. We're going to write our definition down this way. B is the base. Write this on your paper above this box. P is the power, and that would be equal to some number. That's what we did in the last unit. We had exponential type equations. The log equation is the inverse, and it goes like this. This would transfer to a log by saying log base B of n equals P. That is the connection between the exponents we did before and the logs we're starting to do now. Now, please look at it carefully and make sure you copy down the formula correctly, because if you copy down the formula correctly, is it very likely you'll get the right answers? Okay, so yes, you need the formula correct to get the answers correct. Now, did you get the formula correct? Okay. Now, all we're doing today is changing from one form to another. We're changing from exponential to log and log to exponential. What comes next is then solving these kinds of equations. So please look at example 1A. It is in exponential form, and we're going to change it to logarithmic form, and the abbreviation for logarithm is log. The base is 3 of 9 equals 2. That is the correct way to write a logarithm. This 3 right here is called a subscript. It is small and a little bit lower. The logarithm is most interested in the exponent. It is equal to the exponent. Log base 4 of 1 over 16 equals negative 2. Do you have that? All we're doing is changing from one form to another. We're not even asking the question, is it true? It is, by the way. But we're just changing from one form to another. These are in log form, so we're going to change them to exponential form. The log of the base is 5, so the log of the exponent is 5. This number becomes the power, and that is equal to the 25. It helped some of my students when I did this last year. We start at the base, we raise it to the exponent, and it's equal to 25. We start at the base, we raise it to the exponent, and it's equal to the 1/4. Do you remember why this is a fraction? Because this is a negative exponent, this is a fraction. These are in log form. We're going to change them to exponential form. This is the base, this is the exponent, and it's going to be equal to 81. Now, all we're doing right now today is writing it down. What comes next is solving for x. Anybody know what x would be equal to in this problem? What number would you have to have there for your base if you're going to raise it to the 4 power and it's going to be equal to 81? If I had my chart up there, could you do it? It is 3 to the 4th power would be equal to 81. And so this is the base, this is the exponent, and it's going to be equal to y. Now, you cannot solve this equation without some more information. If it has 2 variables, you have to have 2 equations in order to figure out what the x and y are equal to. And that is all.